An organic molecule with the formula C5H10O gives the following proton NMR spectrum and infrared spectrum. Identify the molecule that best correlates with these spectra. So we have two different spectra, and we have four possible molecules that all have the same molecular formula. So I think I will look at the proton NMR first to get an idea of what functional group I can see. So in this higher part of the IR spectrum is where we see bonds to hydrogen. And these peaks here, right below 3000, that's usually our 3000 is our dividing line between sp2 and sp3 carbon hydrogen stretches. So these are just below 3000, so these are our sp3 carbon hydrogen stretches. And then we also have two more signals in the CH stretching region, and they're kind of low for sp3CHs. Actually, they're too low to be sp3CHs. This is indicative of the carbon-hydrogen bond of an aldehyde. So it is that aldehyde bond that we're seeing. So we know that we have an aldehyde. So that means that we do not have this ketone C or the alcohol D. And we should also notice that we don't have an OH for an alcohol. If we do have an aldehyde, we would expect to see an intense peak for that carbonyl, and here it is. So that is the carbonyl peak. All right, so the IR gives us information about the functional group, but it can't distinguish between two very similar aldehydes such as we have here. But if we look to the proton NMR, this will distinguish. So we see we have one hydrogen, and it's approximately at like 9.5 ppm. Well, that's our aldehyde proton. So this is consistent with the information that we're seeing from the IR spectrum that we have an aldehyde. And then what we see here down round 1, we have 9 equivalent hydrogens, and it's a singlet. So we only have 2 signals in this NMR spectrum. So recognizing that we see 2 signals might be enough, because we would expect for this molecule here, B, right, that all of these methyl groups are equivalent. So that would be 1 signal, 2. We'd expect to see only 2 signals in the proton NMR. And if we contrast that with our other aldehyde, the only hydrogens here that are chemically equivalent are the hydrogens that are attached to the same carbon atoms. And so for this molecule, we would expect to see 1, 2, 3, 4, 5 signals in the proton NMR. NMR. So 5 signals, but we're only seeing 2, right? And we can also explain this is 9 hydrogens because we have 9 equivalent hydrogens. So that's 3 equivalent methyl groups. And this is a singlet because there is no neighboring hydrogens.